Hey, this is Don from Padlock Technologies with another video. This time I got a question on encryption with OSPF. Now, if you don't know anything about encryption in OSPF, it is not something that you can do in OSPF v2. But OSPF v3, you can actually do it, right? Or IPv6, right? Now, I'm going to be using a different OSPF. Now, normally you would just do IPv6 router OSPF. But what I'm going to do in this example, I'm going to use the OSPF v3 version of, IPv6 um, OSPF. Now, with OSPF v3, you can actually do address family IPv4. So even though I'm enabling OSPF v3 and having IPv6 enabled, I'm only doing this for IPv4, since you can do that, right? And then we're going to put encryption on top of uh, the control plane packets so that you can't see anything in there. Now, let's just be honest here. When you do authentication in OSPF v2 or v3, all you're really doing is you're authenticating the control plane packet. If you Wireshark it, you can still see what's in that packet. And it's really something that, hey, I trust this control plane packet that's being sent to me because we're using the same authentication hash. It's not really that much of a security mechanism when it comes to like wire sniffing, right? Now, if you got somebody that's on the wire sniffing packets, you got a way bigger problem, security problem than just, authenticating between peers. But the encryption, what that does is it will encrypt the packet using ESP, and then you'll just see a bunch of gobbledygook if you're on the wire trying to sniff it, right? So you won't be able to see what's being sent to the other parent. And I'm going to show you what that's going to look like in a lab. I'll pull up Wireshark so you can see it. And then once we enable ESP or the encryption mechanism on OSPF v3, you'll see exactly what happens to the packet, right? And again, for the most part, a lot of people, they don't use encryption on the packet because you do have to specify an SPI or some security parameter index. You can do null as well. That's what I'm going to do in the lab. I'm not going to specify the actual key, but I'll walk you through it. And then we'll do the authentication on the other end. And then you have to specify another key for the authentication. This one, we're going to use SHA-1. So we have to use like a 40-bit character or something like that, or 40 character length. And then you'll see once we enable it, it turns on crypto. And then you'll see those packets will be encapsulated in ESP. Let's go to the lab here. All right, very simple lab, 2 routers. But if you did this in real life, obviously you would do this all to your whole routing environment. But we're only going to demonstrate this with 2 routers because that's all you really need. So first things first, I'm only going to Wireshark one side of this so you can see it. So let's capture G1 on router one. And then when that comes up, I'm going to put that over on the lower right hand side here. As you can see, we are seeing some hello packets, right? Obviously, since we have IPv6 enabled, we're going to see that from the link local addresses for the adjacencies. We're not going to really see that for the um, IPv4 addresses on here, so you won't see that. And you see that the destination is to our FF02 colon colon 5. So that's really the OSPF router address, right? Just like FF02 colon colon A is EIGRP. So let's go to router one here, open that up. And you know what? I'm gonna open up router two while we're at it, so we can keep this in the right-hand corner. All right. So now let's pull this over. Now we can see the packets or whatever 3 times. We can see the packets currently on Wireshark. And if we clicked on any one of these packets, we can actually see the information here. So here's the OSPF header with the OSPF information, and then here's the hello packet. And obviously we see active neighbors, we see whatever options we're using, stuff like that. Everything works perfectly fine. At least we can see it. Now, when we enable OSPF v3, and I'll just show you from a router perspective what I did. Now, even when you do IPv6, you still need to give it an IPv4 router ID. That has confused a lot of people. Why do I need to have IPv4 if I'm doing IPv6? Just by the RFC and this the way it's configured, the configurations always have to have a IPv4 style router ID, even if you're doing IPv6. Now I did enable it for IPv4 and IPv6. You have to have that. And then if we look at our show IPv6 interface brief, we just got link locals on loopback and G1, which is just the connecting interfaces on both sides. So now, if we look at the route though, show IP, if I did show IPv6 route OSPF, we don't have anything there, right? But if I do show IP route OSPF, we don't have anything there either, right? Now, I got to see if the adjacency is up, which let's see. So run, let's show the OSPF v3 neighbor. So we do have an adjacency there. Let's see if we got anything here. All right, we're good there. We have the point to point. And then let me just make sure the loop back. All right, so that's there, that's there. And just show IP route. Actually, yeah, show IP route. Let's see here. Yep. Here, there, OSPF. And then show IP route should show me an OSPF route. So we have the neighbor adjacencies and we have the route from the other side. If I try to ping .2 from source one, we should see that ping as we see right here, the ICMP echo packets, right? So we still see all this stuff. Now what we're gonna do is I'm gonna say ESP. So we don't have an ESP package yet, but we're gonna enable it now. So what we're gonna do is on G1, I have OSPF v3 network point to point. When you do OSPF v3, the commands are the same as v2. You just have to specify that version. So OSPF v3 network point to point is the same as saying IP OSPF network point to point, right? If you were doing the IP6 version, you would just do IPv6 OSPF network point to point. I just like using OSPF v3, but it's up to you the way you want to do that. Now, unless you're in the lab and they specifically tell you to do OCF v3 version of this, you can use whatever one, IPv6 router OSPF or router OSPF v3, whatever. So now to enable it, the encryption, we're going to actually go under the interface and you're going to have to do this on both ends. So once we put it on here, I'm going to show the interface again, copy it and paste it on the other side. So what we need to do is OSPF v3 encryption, right? And then we're going to say IPsec, and then we're going to say SPI ESP or SPI, which is security parameter index. If you're doing anything with crypto, you're going to have an SPI for inbound and one for outbound. But we're going to just give it this number. I'll just do 0110, and then we're going to say ESP. Now I'm going to null this, but I'm going to show you the type of encryption algorithms you can use. So you got the data encryption standard, you got triple DES, which is just running DES 3 times, and then you have AES, which is a block cipher, 128 block cipher. But we're not going to do that, right? So I'm going to say null, and then I'm going to say this is for authentication. I'm going to say SHA-1, and then here's where I'm going to put the long string. So I'm at 1, 2, 3, 4, 5, 6, 7, 8, 9A, 1, 2, 3, 4, 5, 6, 7, 8, 9B, C, and watch. So now you're going to see crypto get turned on. And now you see those ESP packets starting to come in. All right. Now, because we're not doing it on the other side, adjacencies will eventually, if I don't do this fast enough, the adjacency will eventually drop because I'm not doing ESP on the other side. So let's see if we can catch this beforehand. So all I'm going to do is copy this here. And you can see why a lot of people don't really go this way because it's a lot of work, to be honest with you. And now our adjacencies, that dead timer went down, so we got to wait for a little bit. And now the adjacencies should come back up. So now we have those ESP packets. And if we click on any one of these, you will now see we cannot see the OSPF header or packet information because it's encapsulated in ESP, right? Or yeah, ESP. It's encapsulated in that. So it's basically a bunch of gobbledygook that you're going to see, right? So if somebody was sniffing the wire, they couldn't see it, right? So this is using cryptography to prevent someone from sniffing on the wire. Now, if we do that same ping, let's see what we see now. This is only for, let me just verify this. So to source, let's see. Now I got to take off ESP here so we can actually see here, ICMP. So from the ICMP standpoint, you could still see that it's ICMP, right? You could still see that. But what you can't see, again, is the control plane packet information because it's all ESP, right? So this does not protect, this does not encrypt the actual data. It encrypts the control plane packet. And when you put authentication, it also authenticates the control plane packet with the peer. If I'm still pinging from one side to the other, you could still see those pings because I am not encapsulating the ping messages in ICMP. So do not confuse this if you ever get on a test or you're trying to configure this. You will see the data going through here. What you won't see is the control plane packets between the peer. So if someone couldn't really guess your network unless they do a packet crawl. But again, if someone's on your network doing some reconnaissance, you got bigger problems, right? Because someone's in your network. So hopefully this video was informative. If you like videos like this where I break down certain technologies in layman's terms, don't forget to share, comment, like, and subscribe to the video. Share it on your socials so we can bring more people into the community and, more people get this knowledge because my goal is to, I want to be that network engineer mentor for people that I wish I had when I started out in the game. So I'm trying to be that for you guys. It's Don from Padlock Technologies again. Thank you and have a nice day.